All right, this is my second and last video for tonight. That'll make me done logarithms, and then I can move on to another topic in calculus, or maybe I'll mix it up and do some vectors. All right, so this is applications of logarithms, and maybe you think you've done this before, and you did in advanced functions. You might have also done it in science class. The thing about the olden days of advanced functions is I had to set up the questions specially. So, for instance, here's a question. And it says, a bacteria culture starts with 2,000 bacteria, and after 3 hours, the estimated count is 10,000 bacteria. What I had to do for you in advanced functions, or what that curriculum had you do, is I had to tell you how the culture was actually growing. So I had to say, oh, it doubles every so-and-so, it triples every so-and-so, or I had to give you an interest rate in the example of compound interest. So I had to tell you what specifically was happening to what we were talking about, money, bacteria, wolves, whatever the case is. Now, when we're in calculus and when we're in science, I just tell you that things are growing, or I tell you that things are decaying, and you end up using this general formula which uses that special number E, that 2-point blah, blah, blah. So this is a formula. If you don't like these letters, I'm sorry, you're stuck with K. K is a constant. It is specific to each question. I'm going to say you got to be stuck with T, because T means time, and that's a really, really nice letter to use. But this Y and the Y not, maybe you don't like that so much. So what we could use instead, and I've seen this in some science textbooks, is this. I don't know why my pen is not working fantastically. So that. So the Y naught, the Y sub 0, subscript 0, is replaced with the letter C, and the final value is replaced with the letter A. So I'm going to use that because I think it's a little bit less tricky to keep putting this down. And I just decided that because my pen isn't working fantastic. So hopefully it's just the purple. So I'm going to write this down again. I thought I could get away with cloning it, but apparently I can't. Oh my gosh. This is going to be a painful note, but at least it'll be slow. All right, so the question says, find the number of bacteria after T hours. So I'm going to pull this down here. Oh, it just unglued. There. And we have to do some figuring. So don't just assume that we're going to have an easy time with question A. Basically, A is saying, make me a formula. But based on this list, K is a constant specific to each question, we're going to have to find the K value. And this is going to take some logarithm or E or natural logarithm work. So I'm going to put some values in. And I'm not going to do this stuff off to the side like I did in the olden days. I think we can just plunk it in. So it says a bacteria culture starts with 2,000 bacteria. So that is the C value, the initial population. So I'm going to put equals, nope, it's the whole thing, 2,000. And then I'm going to put an E, and then I'm going to put a K, because I have no idea what that is. And it says after 3 hours, the count is 10,000. So we have to get this K specific to this question, so that we can put it into this formula so we can have a formula that works. Something that is going to be for sure is the 2,000 and the E. And we'll also have a T up here. I just want to make sure I figure out the K first. So our first step in achieving K all by itself is to divide both sides by 2,000. So that is 5 equals, and then we have E, and I'm going to write that as 3K. So hopefully you remember how to get rid of an E. The backwards of E, the opposite operation of E, is ln. But something you are not allowed to do is this. And you're thinking to yourself, what's wrong with that? I can just kill off these guys and write 3k. And that is true, but you have to keep things balanced. So you have to ln both sides, not just one. So on the left-hand side, I still have ln 5, and on the right, we achieved what we wanted to achieve, and that is getting the letter down on the ground. So next step is getting the letter isolated, so I'm going to divide both sides by 3. Shift B down just a little bit. And I have a nice little k value. Now, to be clear, this is ln 5, all of it over 3. It is not ln 5 over 3. So you have to make sure the ln 5 is over the 3. And now I can take that and put it up here. So I'm going to be very careful and attempt to be very neat. That'll be ln 5 all over 3. And then I'll need a t beside it. So maybe using 2 lines on the page is a really good idea. So I'm going to go on and I'm going to answer this question. Find the number of bacteria after 2 hours. And you're thinking to yourself, how am I supposed to know about taking the derivative? You just wait. So I'm going to take this formula and I am going to pick black, and I'm going to carry on from this point just to save me some writing. And I want to know the number of bacteria after 2 hours. Now this is going to require you to learn how to use your calculator, or me to show you. Now I can only show you on this one, so you're going to have to figure it out on your own if you've got a display model calculator. It's probably way easier. You probably have an answer button. Ask me about it. So I'm going to do the exponent first. So I'm going to have 5 and hit my ln button. So that's the ln 5, the whole ln 5, divided by 3, so that's the bracket, times by the 2, that's the exponent, which you do not want to round. Okay, you want to be accurate. You're a scientist in this case. So I have to take that and I have to put it on the E. So I'm going to hit the E button and see what the heck happens here. And bad news. It didn't do what I wanted to. And I don't know how to use my memory buttons, so let's see what I can do here. There's my answer. This is embarrassing that I don't know how to use a calculator. See, I told you using the calculator was the hard part. Get this out of here. So, E... I need to use my exponent button because this is a budget calculator. So there's E, the whole thing, don't round it, to the exponent, bracket, 5, hit the ln button because mine is backwards, divided by 3, times by 2, and the bracket equals. There is E to the giant decimal I told you not to round. And then I'm going to times by 2,000, and I get that. So I'm going to write that down. 584804. 584804. 584804. So that's how many bacteria there are after 2 hours. I'm going to give this a therefore statement and say there will be, and I know he said not to round, but you don't want to round your answer and then round again, so I'm rounding at the very end. There will be approximately 5848 and dead bacteria. So back to your question that I am making up in my head. Your question might be, how on earth do I know when I'm supposed to take the derivative? This is a calculus course. She told me I had to take the derivative. And the answer is right there. That word, or the word tangent, says take the derivative. So you are now in calculus class. But to get there, you needed all this stuff. So I'm going to write this down again and drag it. A equals 2000 e to the ln 5 all over 3 times t and we want to find the rate of growth after 2 hours. So I need to take the derivative. Now normally I would put dy by dx, but this is a's and t's instead of y's and x's. So my next line will be dA by dt, the rate of growth with respect to time. So I'm going to toss down this 2000, then I'm going to take the derivative of e. Well, the derivative of e is itself. So that's easy. But then don't forget that you have to times by the derivative of the exponent. So this is like 5t or 2t or negative 7t. And when you take the derivative of that, it's just the constant out front. The problem is your constant is ugly, and you think, okay, well, if it's ugly, I must have to do more, but that's not the case. I have led you scaffolded very well because I asked you about 2 hours in part B and then 2 hours in part C. So I am going to put 2 in here. Maybe some of you can see the awesomeness about this. The awesomeness is that, I don't know if I can do full page. This 2000 e to the ln 5 all over 3 times 2 was this value. And that's exactly what's sitting right here. All I have to do is hope that I have saved it on my calculator, and I have to times it by ln 5 and then divide it by 3. So I can use this answer to take care of all of that because I scaffolded well. So keep your fingers crossed for me because I don't want to punch this all in again. Yay! Times 5, and I hit my line button because my calculator is backwards. I'm going to hit equals to finish that off, and then divided by 3 equals. And I get 313735. 3137.35. Now this is a rate, so I'm going to totally allow decimals here as opposed to a number of bacteria. Now because it is a rate, that means we can say it is growing, because it's a positive rate. It is growing. The population is growing at 3137.35 bacteria per, because it's a rate, hours. It's not minutes, it's not seconds, it's whatever's in the question. Now, I don't see any hint of derivatives in this question because there's no rate, there's no tangent, there's no nothing. So I am going to start again with, that blue thing. I'm going to see if I can clone it. Oh, I'm so smart. All right, so the question is, when will the bacteria population reach 18,000 bacteria? That is the end result. So I have to take the A and I have to turn it into 18,000. And then we have to do some nifty algebra, not some nifty calculus. It's actually worse because usually people forget their algebra but further calculus. I do not know why I wrapped that t in a bracket. It doesn't matter one bit. So step 1, get rid of this 2,000, which has nothing to do with the exponent. So that will be 9 on the left. Now, I'm going to show you how to do this question twice. Next step, I am going to lawn both sides. And my hand is cramping again, so I'm going to squeeze that in there. And notice how I lawn both sides. What that means, actually I'm not going to show you, I'll show you with the next one. That means you can wipe out those guys. And on the right, we have ln 5 all over 3 times t, and on the left-hand side, we still have ln 9. Next step, this is a divided by 3, so I'm going to fling it over here as a times by 3. That means it's going to disappear on this side. And you want to keep this ln 5 in a bracket with the t on the outside, because if you write it like this, that's the ln of 5t, and you mean the ln of 5 multiplied by t. Totally different story. And then, to get t by itself, we can divide by both sides by ln 5. And no, you cannot cross out these lines. That's bad math. Excuse me. And that was bad timing. All right. So the t value will be whatever 3 ln 9 divided by ln 5 is. So I wrote it there. I'm going to do the bad math double equal sign. So you can see what it is that I'm punching into the calculator. So I'm going to do the ln of 9 first, then I'm going to times it by 3, and then I'm going to divide it by the ln of 5, and I get 4.095. So I'm going to say 4.1. And what is this unit for time? Hours, like everything else. Therefore, it will take 4.1 hours. All right, let's see what this last question is all about. Oh, more science. So this one is radium decays at a rate that is proportional to its mass. So this is a decay question. I'll show you the difference that makes in a minute. Given that the half-life of radium is 1,590 years, and that 20 grams of radium was present initially, how many years would it take for 90% of its mass to disintegrate? So because we are in calculus now, we have to take this formula and we have to find the specific K value. So if we start with 20 grams of radium, and we don't know what the K is, but we know that after 1,590 years, there is half of what it used to be, I should put a 10 over here. So this is going to help us find our K, because the only thing missing is the K. Divide both sides by 20, because it has nothing to do with the exponent. Yes, that creates a decimal, but it's not an awful decimal. And you should do this every single time. So I'm going to reverse this. So you start by finding your K value, because now you're in calculus. I'm going to jam this in. Both sides. So ln 0.5 equals, ln and e's cancel each other out when there's nothing in between. So I get 1,590K, divide both sides by 1,590. And this is the same deal, but nastier numbers. The K, the specific K for this question, is ln 0.5 over 1,590. Now, how do you know that this is working out to be a decay, should be your question. So if I go back a question to find the K here, so I figured out that K was ln 5 divided by 3. You can check to see if this is a growth question. that doesn't work. So let's leave it there. So 5, hit the ln button, equals if you want to. Oh, no, apparently not with my calculator. 5 with the ln button, and then divide by 3 equals, this is a positive number. It's not a very big positive number, but it's a positive number. If I go to the second question, and I do the exact same thing with my k value, 0.5, hit the ln button. Oh, look at that. Divided by 1590. It's decay because it's negative. It doesn't matter that it's a super little negative number. It matters that it's negative. Negative means decay. So you know you're on the right track if your k value is a negative and it's a decay question. So now I've actually got the bulk of a formula. So I've got A equals 20 E ln 0.5 all over 1590. So you can see how difficult this is to write. And also a t. And I need to figure out what 90% of 20 is so that I can put it in here. So actually we want 90% for it to disintegrate. So 90% of 20 is 18. So 18 grams of this stuff is gone. We don't care how much is gone. We care that there are 2 grams left. So I am going to put a 2 in here. Now, this is the question I'll do twice, mostly because my pen is working now. All over 1590. So we'll do it the way we just finished it in the last question, and then some of you might want to block out my voice. So divide by 20, because it has nothing to do with the t, and we end up getting, I think that's 1/10, which makes sense because if 90% of it's disintegrated, 10% is left, and that's 10% as a decimal, equals e to the ln 0.5 over 1590 t. Save myself a line. I want to get rid of the e to get the exponent down on the ground, so I have to ln, but I have to ln both sides. So ln 0.1 is equal to gone ln 0.5 over 1590 t. Now, I don't know if this is too fast for you, but if I do a half cross multiply, that will multiply this 1590 times ln of 0.1. And then I have this, and remember this is multiplied by the t, so the t isn't enclosed in it. And then I have divided by ln 0.5, divided by ln 0.5. But for some of you who totally understand your fractions, if you divided both sides by ln 0.5 over 1590, that is the same thing as dividing by a fraction. And when you divide by a fraction, you times by the upside down, and here is the upside down. Timesing by 1590 divided by ln 0.5. So hopefully that cuts down on some people's steps just by me saying that. That is not the alternate method. So still bear with me. Don't panic that the answer is negative because I still have to divide by 0.5. Hit the ln button. There's another negative number, so we end up with a positive. So 5281.9. 5281.9. Therefore, it will take 5281.9. You're sitting there thinking, how does she know it will take time question? Well, t is time. I just have to remind myself what was going on. So it takes 1,590 years to get to half. So this is half and half and half again. So this is way more than that many years. but it also gives me the fact that this is in fact years. Now, for those of you going on to calculus class, there's a little trick you can do, and I almost hate to tell people about this, but I think it's worth it because I don't want you to look at textbooks and think, where the heck does that stuff come from? So some of you might want to block me out right now, but I'm going to show you an alternate way. Where did that come from? An alternate way to get to this answer of 5281.9. I probably will have to write big. So remember what we're looking for. So this is a logarithm, which means I get logarithm rules. So really what this bracket is, and I'm going to write it here so I can write big. This, believe it or not, without the t, is the same thing as this. Because this is just over 1, so you multiply across the top, multiply across the bottom, and get it back to that. So that means I've got a number, an ugly number, sitting out front of a lawn, so I can use the reverse law of powers to do this. And remember, there's a t sitting there, and there's a t sitting there, and there's a t sitting there. So let me put that here. Only I'm going to write it. No, I'm going to write it like that. Oh, see why I paused? All right, so that is the same thing as this. And this would be fantastic if this t wasn't in the way, because then I'd have an e and a ln in a row. So why don't we use the law of powers, because we've still got lns, to fling that t where? Up here. And remember, we are heading for this to be 2, just like the last question. Right there. So, to save myself a little bit of time, got this, and then I don't want to write the 20 and the 2, so I'm going to divide by 20, and get my 0.1 again. And then you can ln both sides, drag this back down, and punch it in. So hopefully from here you are a little more familiar. But I wanted to show you that you can actually manipulate that exponent. Now I'm not going to write this up here, I'm going to write it here. So I'm going to write 1t over that, which means if I want to get the 1t by itself, I'll have to take 1590 times the ln 0.1, so I'll fling that up in a multiply, and then divide by ln 0.5, and that is exactly what happened here. So it depends on how you want to manipulate it, and that's the thing that I do like about math, that I can actually do things in more than one way. Now, sometimes some of you are going to look at me and say, why would I do this when I can actually just resort, that's how it happened. I can actually just resort to using my calculator and use basic skills. And the answer is, yeah, that's great. Do that. Just learn that well. So this is the stuff, this stuff on sheet C. And there's also some review of your ln and log exponential growth and decay, maybe even some compound interest. I can't remember. So anyhow, that is it for logarithms, even though this note is going to come before the logarithmic differentiation one. Oh, that's still not bad. See ya.